quiz, but I can do after class.
This
Okay, thank
meeting
you.
is being recorded.
So we are going to talk about Hess's law of heat summation. It's a law. It does not explain anything. It's generalization of many experiments or many observations. Heat summation. Heat meaning specific heat. Heat meaning heat of reaction. Heat meaning enthalpy. That's what we mean, enthalpy, heat of reaction. Addition, you can add enthalpies. That's what we're talking about, addition. Hess's law of heat summation. And you are not going to use the lab manual to write your reports. Please don't do that. I have given you specific instructions. And even then, people did not read the instruction and just kept on doing it. And we talked about it in the class too. Please don't do that. Okay. Why not? Because some people send me, most of the page was procedure. What do I care about the procedure? Don't I know the procedure? I don't want to read your procedure in your report. Please. Now, excuse me, people are getting good about doing the table. So that's very good. Please keep on doing that. Tables are, they have to be neat, and you understand that now and you're doing that. So that's very good. And the last report that I did was the heat of reaction, not the heat of reaction, the specific heat capacity of aluminum and lead. Most people did a pretty good job of it. So that was good. Only a couple of people made a simple mistake here and there. So that was nice. Excuse me. That was nice to see that. So we go over there and we look at the experiment. We want Bjorn lab.
Hey, Professor.
Yes.
In the heat of reaction lab, I actually got, for all 4 of my trials, I got the same answer for each one.
Same answer for each one.
Well, just the mass starts out at the same. The mass of the water starts out the same.
Oh.
So it ends up just they all came out to the same value.
Oh, well, so then what can we do about it? You did the 4 and they're the same value. So then you don't have any percent error. I mean, you don't have any relative range is 0.
That's what I realized, but I just want
to write that. We can't do anything about that. Okay, that's fine. Beyond Labs portal. Log in. Connect. Okay. Hess's law of heat summation. Thermodynamics. Hess's law. Okay, we have our usual suspects here. We have the balance. We have something on the balance that's already measured. We'll write that down. What is that something? We want to write that down. We have NaOH 100% here. We have units, energy units. We don't need to be concerned with that. Those energy units are not important. We have a calorimeter over here. We find out what is the temperature, 24.99 degrees Celsius. Only one person made a mistake about delta T. Delta T, as we talked about it, is the same as degree Celsius and Kelvin. Do not have delta T calculated in degree Celsius and add 273. Do not do that. That's wrong, and I've shown you why it is wrong. And it's also in the guidebook. So that one person should consult the guidebook and make sure that it does not make that kind of mistake again. Okay. And we have this temperature that's showing is pretty much 25 degrees Celsius. That's the temperature. Now we're gonna add things, and let's go to now to go over here. Hess's law. No, this is what you are going to use for your report. Write 3 equations for 3 processes. What do we have? This is what you are going to use. This is your data table. And keep on doing the good data table that you are doing. And sometime I understand when you write a table like that, when you give it to me, the table disappears, but the data is there, so that's okay. So calculation, this is what I want you to calculate, and results table and all that. So that's what it is, post lab. This is what you are doing for your, and don't give me anything else. I don't want procedure. It just takes up space, and then you say, I could not send the whole lab in one piece, so I have to send it in many pieces. Well, yeah, if you are sending me procedure, if you're sending me something, almost the whole page of procedure, 2 pages, then of course you're gonna have a harder time sending it to me, please. Please, thank you. So this is how your report is gonna look like. Now let's put it over there in case we need it later. Come on. Okay, there. Oh, dang. Oh, come on. Ah, this is ridiculous. I don't want this thing here. Yeah. I don't know how to deal with this. This never happened to me before. I guess I'll have to put it on this side of this. And I'll have to change this, take this and put it over there. Okay. Put this down below. Get rid of this, I don't need that. Put this over here. Okay, that'll do to a certain degree. Put this down below here. And we're gonna go into virtual lab. Okay. Hess's law, thermodynamics. Okay, heat of vaporization. Hess's law. 312. But that's, Okay, 312. Three 6. 313. Okay, there we go. It's so easy to heat of combustion. I don't want that. Heat of formation. Heat of formation. Heat of, there we go. Hess is low. In this experiment, you will measure the amount of heat released in these three related exothermic reactions. After determining the heat of reaction, H1, H2, delta H3, you will then analyze your data and verify the Hess's law or H1 plus H3 equals H2. I like to do it H1 plus H2, but minor matter. Start with your lab. Okay, we did that. Reaction, there will be a bottle of NaOH. Okay, 200%, everybody can see this. If not, I can increase the size. Okay. A bottle of NaOH, sodium hydroxide. A weighing paper will be on the balance with the approximately 4 grams of NaOH. Record the mass of NaOH in the data table on the following page. So record the mass, everybody. 3.9983. Is that what I see? 3.998C. Is that what you are writing it down? Okay. NaOH. The calorimeter will be on the lab bench, right there, calorimeter, and fill with 200 milliliter of water. Write down 200 milliliter of water, and 200 milliliter equals 200 grams. That's how we're gonna do it. Make certain the stirrer is on. Stirrer is on. Let's see. It is on because I can see it moving. Very hard to see it, but it's right there. It's moving. Okay. In the thermometer window, click Save to begin recording data. Save. Okay. Allow 20 to 30 seconds to baseline temperature. Number 4. Drag the weigh paper with the sample to the calorimeter until it snaps into place, and then pour the sample into the calorimeter. I am very happy that this experiment is a virtual experiment. I would not want to do this experiment in the lab. Well, I would, but I would not want you to do it. It requires finesse. Remember, we talked about some chemicals we don't touch, most chemicals we don't touch. And now NaOH solid is one such chemical. You do not want to have any of it on your anywhere. NaOH is a very strong base. And as soon as it touches water, a little bit of water on your skin, it'll start dissolving in it. And NaOH is a very strong base. It'll start hurting you, burning you, destroying you. Yes. So if this experiment has to be done, I would not trust it with chemistry 1A student. I would do it myself and do it as a demonstration. Anyway, we don't have to worry about that. So let's see. Drag the weighing paper, observe the change in temperature until it reaches a maximum, and then record data for the addition 20-30 seconds. So we know how to do that. So you're gonna write it down. You're gonna make a simple data table right now, and then you are going to convert that into put it into the data table given by me. And in chemistry 1B, you will have to make your own data table, and those data table will have to be very nicely made. And not only that, they have to be correctly made, meaning they have to show the thing that they need to show. And if you don't do that, the points are taken away right away. So right now, I am providing you with this data table. You learn from it how to make a data table. Okay, this is your opportunity to learn. Normally in chemistry 1A, we don't give out data tables. You're supposed to make your own data tables. Some of the time they are given, some of the time they are not given. But this time, I have decided for many of them, I'm going to give you data table. Maybe at the very end, I'll ask you to make one to see whether you have learned or not learned. Okay. Now let's take that NaCl and dump it in our thing here. Drag the weighing paper until snap into place. Okay. Drag it. Snap, snap, snapped into place. Okay. Now, hey, that is increasing. Look at that. Look at that. The temperature is increasing right away. Yeah. Why is it showing that? I don't know. We need to have this here. Oh, there we go. Okay, good. This is room temperature, 29.74. Everybody keep an eye on this. What maximum we are going to see? That's what the point is, right? It's going to be maximum very soon. Now we can see that it's leveling off. Twenty-one once, 21 two times is 21. 30.21. All right. $18. Okay, 30.21 degrees Celsius. 25 minus 30.21 degrees Celsius, that's 6.21 degrees Celsius is the delta T. And do not convert, do not add 273 to it, please. That is also K. If you want to write down 6.31 K, write that down. 6.31 K equals 6.31 degrees Celsius. Write it down so that you will remember. Okay. Click the red disposal bucket. Now, click the data icon. Where is the data icon? Uh-oh. I don't know where the data icon is. Well, it's okay. Huh? Well, stop. Okay. All right. Let's see. Data link icon will appear in the lab book or in the lab book. Data link icon. Well, you work it out. Right now, we're just going to write it down as it is. Click the data link icon. Okay, report this part, repeat this part. You need to repeat this part. This is what you do. Click the red disposal bucket to clear the lab. Red disposal bucket to clear the lab. Where is the red disposal bucket? I don't see it.
It's on the left.
Oh, there it is. Thank you. Okay. There will be a bottle of NaOH near the balance. Uh-oh. Return to the laboratory. Return to the laboratory. There will be a bottle of NaOH. Okay, so we need to get out of here and then go get back in there. Hess's law of heat summation, S. Now we have, 3.9984 grams. Weighing paper will be on the balance, okay? Record the mass, you all wrote down the mass, 3.998 grams. The calorimeter will be on the left bench filled with 100 milliliter of water. We have 100 milliliter of water now, write it down. This is the part number 2. 100 milliliter of water equals 100 grams. And there will be a beaker containing 100 milliliter of 1 molar NaOH, on the bench. Where is that? Uh-huh. 1 mole of HCl. So we did reaction 1. It's not a reaction, it's a process. It's a dissolving. Dissolving is a process, it's not a reaction, but we can call it a reaction, it's okay. So we did that part. Okay, we are doing second reaction now, HCl plus NaOH. And HCl plus NaOH, there is no HCl here.
At step 5, you have to go to the stock room and select that reaction.
Sorry, say that again.
Step number 5, if you read it, it says go to the stock room and click on the clipboard.
Yeah, but I don't see the clipboard even.
It's inside the stock room. If you go to it, it's on the wall.
There, okay. Okay, thank you. Heat of reaction HCl aqueous plus NaOH solid. That's the one we want. Yep. So we do that. Now we hope we have that. Okay, there it is. That's 100 milliliter of HCl there. 100 milliliter of HCl. Okay, in the thermometer window, click save to begin recording data. Allow 20-30 seconds, okay. Measure, make sure the beaker of HCl is visible and drag it to the calorimeter and pour it in. Okay, freeze, there, done. Now what? Now we're gonna look at the temperature again. It's 25.0 essentially. Let's have the temperature available to us here. Okay. Now drag the weighing paper with the NaOH to the calorimeter until it snaps into place and pour the sample into the calorimeter. So let's do that. Okay, now the temperature is increasing right away because the reaction is happening. It's a very exothermic reaction. Acid reacting with base. So we are looking at the maximum temperature. Okay, it's almost there, 36.48. 49. 49 once, 49 twice. It is sold. 36.49 degrees Celsius. And that started at 25.01 or 25. Okay, that's that. So you know delta T. All right, we go to reaction 3 now. Now we get rid of red, click the red disposal bucket. Okay, now go back. Click on the stock room to enter. Okay, there we go. This is how you do it. You enter the stock room and then you look at this. Now the third is HCl aqueous plus NaOH aqueous. HCl aqueous plus NaOH aqueous right there. Okay, everything is as it is. Now we have 2. What do we have 2 here? For the lab beaker containing 100 milliliter of 0.10000 M. Now I want to remind everybody, please remember this. Remember this, please. Text. And color is fine. M equals molarity. Molarity equals moles over liter. And I caught a few of you doing this. 0.100 M divided by 1 liter. This is wrong. M equals molarity over liter, so you are writing liter twice. If you write M over here, you're writing molarity liter twice. So this actually means mole divided by liter square. That's what it means. That equals mole divided by liter square. Oh, that's not what we want. We want mole over liter. So do not do this, please. Don't write M here. And I would prefer, if you don't write M instead of M, always write moles over liter. Don't write M by itself. If you write it and if you done it right, I wouldn't call it wrong, but I don't like it. Okay. Now we have established our temperature. So write that down. The beginning temperature, initial temperature. Now the left. This is the left one. We're going to put it in first. No? Uh-oh. And then with the right one, we're going to look at the temperature. Is the temperature increasing now or not? It should not. Okay. Baseline temperature is still the same. Now, oh, I was supposed, no, now the right, but did I do it right or not? Maybe I did it wrong. What did I do? For the left bucket, that's what I did. I poured the left one. I did not put the right one. Now this should go in there. 'Okay. All right. It's an exothermic reaction. Temperature is increasing fast. Now you are not going to do this. You are going to go into our data table. Hess's law experiment. (31.05), 31.06, 31.06, 31.05, 31.06, 31.04. There we go. 31.06. Sold once, sold twice, sold. 31.06 degrees Celsius. Okay. Now what? Now we're gonna stop that. Stop. All right, you're gonna write it down. Data table reaction 1, mass of NaOH. You write it down over here. If you can print it out, do it. If you can print it out, make a neat graph with a ruler and write it down. Initial temperature, final temperature, delta T. I want delta T to be over here. Reaction 3, initial temperature, final temperature. Remember, the mass of NaOH is not in reaction 3 because we had a liquid NaOH. We had, sorry, not liquid. We had aqueous NaOH. So that's why the mass is not there. Like calculation. Process 1, process 2, process 2. Calculate the mass of the reaction mixture in each reaction. So pure water, 1 gram per milliliter. So that's what you do. Fine. And calculate Q, the heat, total heat released in each reaction in joules. And this is going to be heat released. Therefore, it's going to be negative joules. And everybody knows how to do the specific heat capacity. Use the specific heat capacity given here. And then you calculate it. Everybody knows how to do that. Calculate the number of moles of NaOH used. That's also everybody knows how to do that. Calculate delta H process, the energy released in kilojoules per mole of NaOH for each reaction. Record the results. In kilojoules per mole, so you are going to have Q here, and then you're going to convert Q to delta H by taking into account how many moles of NaOH you had there. Okay, results table. Mass of reaction mixture, delta T. Again, you're going to write it down again, delta T. Total heat release, this is going to be Q, and this is going to be delta H per mole. That's delta H per mole. And total heat release, Q is 4 grams. And mole of NaOH is what you are going to calculate. And I can change that. Yeah. Show that the equations for reaction 1 and 3, which are given in the background section, add up to equal the equation for reaction 2. Well, you're going to write this equation. Very simple equation. Solvation of NaOH, no reaction is happening here. Just NaOH is breaking down into ions. Everybody knows how to write this equation. Everybody knows how to write this equation. So equation 1 plus equation 3 equals equation 2. You're going to show that, and then you're going to do it. Calculate percent difference between the heat given off in reaction 2 and the sum of the heat reaction. Assume that, okay, percent difference. State your own words, state in your own words what it means by the additive nature of heats of reaction post-lab. So you are going to do 2 of this on your own. Huh? No, there are no 2 to do on your own. That's it, very simple experiment. Very simple experiment, and you have all the data that you need. So you are going to do the calculation right now. You're gonna get this done today in the lab time. And then we'll talk about Hess's law of heat summation again after you're done. So this is what you're doing right now. You have your readings. You're gonna finish this equation, writing this equation. And then you are going to fill in the data table, do the calculation, and we'll write down the results and send it to me, and you'll be done. So that's what you are doing right now. If you have any question, you will ask.
Sounds good, Professor.
Yes. If you want to take a break, it's up to you. But I expect you to finish this today. And we're going to do more because there is a lot more time. We're going to talk about Hess's law again.
So, Professor, just to repeat, what was the final temperature for reaction 1?
Okay, somebody, what was the final temperature for reaction 1?
And that's with the 3.9983 grams of NaOH.
Well,
Is that the first one or the second one? Because
Yeah,
wasn't the
that's-
first one 30.1?
you know, if you are not sure about this, it's very easy to do the reaction. It won't take you much time.
Okay, I can just do it again.
Yeah. This time I did not write it down myself. I have not seen any 10 easy points like this. But I decided, oh, let it be that way. Okay. So everybody already got these 3 points because we did it.
Professor,
Yes.
how do we find the mass of the mixture?
Oh, what do we have in the mixture?
Uh, for the second one, we have HCl and
Go on.
HCl and NaOH,
How much HCl we have there?
100 milliliters.
And 100 milliliter equals 100 grams,
It does.
right there, you see,
They give you the molarity of HCl too.
right? No, we don't need molarity. Well, we do need molarity, not for this calculation. The density of the solution is the same as the pure water, 1.0 grams per milliliter.
Okay.
So 100 milliliter equals 100 grams, both for NaOH and for HCl. And then we took so much, if you put solid NaOH in it, you know how many grams you put in there. So you have your weight, right? Yes?
Yeah.
Okay. 2:38. This should be done by 3 o'clock. And if you can't do it, you need to get help. Makaya, how are you doing?
I'm finishing calculating the heat release.
Good. You don't have any questions?
No, I'm good.
Okay, Lisa, how are you doing?
I didn't catch the first weight on the first problem, so I'm going back and having to do it.
I just redid the 3. I can tell you.
Okay.
Reaction 1, first weight is 3.9983 grams. Reaction 2, first weight is 4.0013, and then reaction 3, you don't have mass.
Okay. And then for reaction 1, I have 30.1.
Yeah, I got 30.19.
19. Okay. And then for reaction 2, I have 36.49, or is that the delta? Is that the plus the 6?
No. That's it. 36.49 is the final temp. Your delta is just going to be final minus initial.
Okay. What was the initial for those?
25.
I have, what'd you say?
All of them were 25 degrees Celsius.
25 degrees. Awesome. Thank you.
Okay.
Now I can get on it.
What about the
Thank you
third
so
one?
much.
You got the third one?
Oh yeah, what about the third one that didn't have a mass?
Yeah, it doesn't have a mass. You start with 25.00 degrees Celsius, then you add in the 2 beakers. My temperature, my final temperature was 31.06 degrees Celsius.
Oh yeah, I have that written down too. Okay. Awesome. Thank you.
No problem.
Cindy, how are you?
I'm here working.
Doing okay? Any questions?
Yeah, I'm just trying to get the delta T. Oh, sorry, my daughter's in class right next to
Good,
me.
you know what you're doing. Good, good.
I think I know what I'm doing.
Wonderful. Okay.
I'm trying. If I get stuck, I'll ask for help.
Amina? Amina, Sal Mubarak.
Hello, Professor.
Oh, hello. How are you doing, Tram?
Tram? Oh no, it's Amina.
I said Sal Mubarak. What does that mean to you? Anything?
Oh yeah. Well, you said Salam Mubarak. I'm guessing like, are you talking about New Year's?
Yes.
Yeah, it was our New Year's the other day. It was really hectic.
Okay. So you're supposed to say something back to me too.
Salam Mubarak to you as well.
Okay.
Do you celebrate New Year's?
No. My new year was a long time ago, 2 months ago.
Oh.
Professor, I just joined. What are you doing right now, if you don't mind?
We are working on this lab. What does it say in the syllabus? Hess's law.
For your
of combination.
convenience, online banking.
So you are going to do the lab. We already did the lab. So you're going to do the lab, and if you have any question, you're going to ask me. That's what it said.
When is it due?
It's due today. That's what I was telling everybody because we did the lab already, finished it. So we are doing the calculation right now. But if you haven't done it, you will do it and get it done when you can and get it to me maybe in 2-3 days. It's a very short lab.
Do we have by the end of the day to turn it in?
That's what I was saying.
Okay.
Is that enough for you or you need more information?
That's good. Thanks.
Okay. Please don't make a habit of joining late every time. Seems like some people are joining late and stuff like that. That's not going to help very much. As I have said, this class is unforgivable. Unforgiving. You missing a few classes, that'll decrease your grade by A becomes B and B becomes C and C becomes D. That's what happens with this class. So please keep up with it. Stay in the class and listen as much as you can and ask questions if you don't know what's going on.
Hey, Professor, for the first
Yes.
part, Hess law experiment, write the 3 equations of the 3 processes.
Yes.
That's just what we did in class, right? Where we just do the individuals and then the heat change and then you add them together.
That's the idea. Yes, that's right.
Okay, it looks like in the actual lab notebook, they give an example of it. It almost looks like a net ionic equation. I'm curious if I can just document it like this or.
Well, can you can you write an equation for solvation of NaOH solid?
Yeah.
Okay, there's gonna have ions in there
Mm-hmm.
because it dissolved, it's gonna be ions. Or you can write down NaOH aqueous, or you can write Na1 plus plus OH1 negative. That's very simple equation. Equation 2 and 3, everybody in this class know how to write those equations, right?
Yeah.
Yep. So that's that. And then you are going to show that equation 1 plus equation 3 equals equation 2. You're going to add those two equations to show me that that's what happens. And then you are going to take the delta specific delta H and then add them up. And if you flip the equation, you have to flip the sign. That's what there is to it. Like you told me earlier.
So there are two labs due today.
Yes, I want you to finish it. I was saying you could finish it in at 3 o'clock. By 3 o'clock, you could finish it. That's what I was thinking. But if you need a little more time, 3:30, okay. And then we're gonna have 1 hour of you me helping you with the homework and talking a little bit more about disorder and entropy. That's what it's gonna be.
That sounds good. So Professor, we're not given delta H 1, 2, or 3, right? We have to calculate that.
Well, you found the delta H for 1 and 2, and you found the delta H for 3 too. And you are going to prove that that's going to work, that the heat of reaction of the reaction 1 and 3 equals the heat of reaction of reaction 2. You all have the 3 delta H's. First one is 5.19 degrees Celsius. Second one is 11.49 degrees Celsius. And third one is 6.606 degrees Celsius, right?
Shouldn't delta H be in joules then?
I'm sorry, delta T I'm talking about. Delta H you will have to calculate, yes.
Yeah.
Sorry.
It's okay.
How do you calculate delta H? If you have Q, how do you calculate delta H? Delta Q is for grams, delta H is for moles.
Hey, Professor.
Hmm.
I'm still having I'm trying to go back on the unit for delta H. Could you
Yes.
possibly just walk through the first one, the most simple one, NaOH solid to
What are the units of delta H? Go ahead, tell me first.
delta H should be kilojoules over mole or
Yeah.
kilojoules?
So did you find Q?
No, I haven't solved for Q yet.
How do you find Q?
Q should be grams times constant C times Kelvin.
Okay, so you find Q.
So we have delta T, and then the constant should be, we don't have the specific heat capacity already, do we?
O is given to you right there. Right here. Calculate Q. Assuming the specific heat capacity of the solution is 4.18 joules per kilogram for Kelvin degrees, gram Kelvin, right there.
Okay, yeah, I was just looking at the top of the lab, the Hess law experiment.
It's all right.
So are we not supposed to fill out the top spot until we finish the lab and then we go back to fill that out?
The top?
Yeah, you just scroll up a little bit to the Hess law
Data
experiment.
table? What?
Right there. Three equations with 3 processes.
Yes, that's right. You will know it then.
Okay, so we fill, okay, that makes sense. That makes more sense.
No, you don't have to fill out anything here. You just add the two equations to show that the third equation is like that. That's all. You don't have to write delta H over here. This is where you're gonna write delta H in the results table.
Okay. This is just a question for the class. For in the calculations number 1, what did you guys get for the mass of process 1? The mass of the reaction mixture.
Oh, 103.9983. That's the 100 plus the mass of NaOH.
So the mass of the solid added shouldn't actually change the volume, right? So it should be 200
We are
milliliters.
going to not say that. Assume that the volume is not going to change.
So you have 200 milliliters in all 3 processes. It looks like it's 200 milliliters.
No, the first one is not 200 milliliter.
Isn't it?
You
Reaction.
added 100 milliliter and 3.998 grams.
I see for, am I Hess law, right? That's the lab we're doing. Shouldn't it be the calorimeter on the bench is filled with 200 milliliters of water?
Yeah, that's what it says.
Yeah.
Well, then it would be 200 milliliter plus. Yes. Oh, you're right. That's what it says. Okay. We are going to 200 milliliter is 200 grams. Well, that's what we are going to say.
That's what I assumed. Okay, that makes sense. And then, but wouldn't that inherently be the same for all 3 processes then?
Same what?
So you have, it's still a 1 gram over milliliter for pure water.
Right.
And it's 200 milliliters for each.
Yes.
So wouldn't it would just be 200 grams
The
for
weight,
each?
you mean? The weight is close to be 200 grams. Yes. For
Okay.
all. Okay. Only the temperature is going to be different.
And Professor, as you said before, in calculating Q, there's not any change between Kelvin and Celsius, right? Because you would just
Yes.
be.
Right. Everybody listen to that carefully. So the first one is going to be 5.19 degrees Celsius or 5.19 K. That's it.
And Professor, are we going to use the sig figs from the specific heat capacity? So it should be 3 sig figs. Or are we going to use it from? I guess from Kelvin too.
Yeah, from Kelvin, 3 sig fig.
For the class, for the first reaction, did you guys get 86.7 joules?
Hey, somebody speak up, please. He's asking you a question.
I'm just curious if I'm doing it right. I'm still not 100% on this chapter.
Wouldn't it be thousands of joules to make it kilojoule?
It says it wants it in joules, right?
Doesn't matter joules or kilojoules. I don't care really.
So you did 4.18 times. Well, for this is for first reaction.
Yeah.
4.8 times 203.9983 times 5.21.
I guess we did it a little differently. I did 3.9984, I guess, for reaction 1 grams and AOH.
Not 3.9984. That's 200 grams of liquid in there.
Okay, so it's 200 grams NaOH?
You told me yourself, you reminded me that there was 200 grams of water in the calorimeter for the first one.
Okay.
So that's 200.3943998 grams total.
Okay. And then you multiply that by the specific heat capacity.
Yeah.
And multiply
And
that.
times the delta T.
Okay, that makes more sense.
Professor.
Yes.
Okay, I'm gonna ask you for help, but help me, okay? Don't make fun of me. I'm not really like I get really confused with the formulas.
I really appreciate your courage. Go on.
Yes, I didn't want to ask. I was waiting. I was hoping somebody asked, but nobody's asking, so I have no choice. So okay, I got like the first part down, but for the calculation part on the first one, it says calculate the mass of the reaction mixture in each reaction. So I have to first determine the volume of the solution, then calculate the mass of the solution based on the assumption that added solid does not change the volume and the density. Well, the first part. For that one, when I calculate, it says calculate the volume. So I have to find the volume first, right?
Well, the volume is given to you.
Volume.
Which reaction?
The first reaction.
It was the what? I'm sorry.
It's given to you as 200 milliliter.
H2O.
So just convert it into grams, 200 grams for water.
200 millimeter. Oh, that's what we had wrote down, huh?
And then add that 3.998 grams of solid in there, NaOH. So you have 203.998 grams of liquid there.
Oh, okay.
And what is Q? Q, what is the equation for Q?
Well, the thing is, the paper that I downloaded to my on the iPad too, because I do my work on the iPad. I don't have the 200, and then I had to fill in the like there was not a. It didn't have like you know how you have the boxes. It
Do
didn't
you,
have the
do you have this paper or not?
Yeah, I have that paper, but mine looked different. Mine's didn't have, you know, where it says the mass and
Law experiment, right? 3 equations for 3 processes, yes?
yeah, I have that, but mine's downloaded differently on my iPad. So I had to draw those boxes. None of the
Yeah, I
boxes.
understand that the boxes can be lost sometimes. I understand that.
And then I didn't see the 200 ml, so that's why I was struggling. I don't have that.
Oh, that was the first time when we did it. That's what we talked, we
Oh,
stated.
Yeah,
it's not-
I'm also doing mine. If you go to the virtual chem lab doc, it's the Hess law. That's where I'm getting all these milliliters from.
Okay, I think that's where I seen it and not here because I was looking and
So-
I'm like, well,
So
how is everybody?
I talked about it and you were supposed to write it down.
Yeah, I wrote it down, but
Good.
I was switching pages on my iPad and I accidentally deleted the page where I wrote stuff down.
So
So
now you know it's 203.998 grams, right?
yeah,
And now what is the equation for Q? How do you calculate Q?
Q. So then that will be
Heat is directly proportional to what? If you have a part of heat, and if you have a little part of heat, which part has more heat? It has the same temperature.
which part has more heat, you said?
Which part has more heat? You're cooking in 2 different parts. A smaller part, a bigger part. You have water in both of them. The water is at the same temperature. Which part has more heat in it?
The big one.
Therefore, heat is directly proportional to what? The big part is these are 2 separate systems.
Mhm.
What is you tell me what is the difference between the 2 parts? They are made up of the same thing.
Yeah, but one is smaller, one is bigger.
Yeah, so bigger. So what is the difference as far as heat goes?
Well, there's gonna be more heat in the bigger one than in the smaller one.
Yeah, that is correct. And so what is the difference? The difference is grams. Different is mass, right?
Yeah.
So
see,
heat is directly proportional to mass. You know that, correct?
Yes.
Yes. Now, what else is heat directly proportional to? One has lower temperature and one has higher temperature. Both parts has the same amount of water. One has lower temperature, one has higher temperature. Which part has more heat?
The one that has the bigger one.
So heat is directly proportional to what?
I don't know. I'm nervous now. I can't even think. I feel like you're putting me on the spot.
Okay, you're telling me that one is
One
one
is
with higher
one-
temperature
yeah.
has more heat in it. So heat is directly proportional to what? Heat is, okay, I will ask you in a different way. Heat is affected by what?
By fire, right?
By temperature.
Yeah.
So temperature, more temperature, less temperature.
More temperature.
You just told me, and you know that.
So it's
So
temperature.
heat is proportional to delta T. This is how we say it.
Delta
This
T.
is how we say it in mathematics. In English, we say the part with higher temperature has more heat in it. In mathematics, we would say it is directly proportional to delta T. It's a different way of saying the same thing. Okay?
Okay.
Now, I'm going to write it down for you and you look at it. So I'm going to say, what is the symbol for heat we have here? which symbol would you use for heat?
The
Is Q, small q. Okay,
Mhm.
is directly proportional. So this is the proportionality sign, yes,
Yes.
and it's proportional to grams multiplied by delta T. We just, you know this thing, right?
Yes.
Delta T. Now we're gonna convert that into an equation. How do we convert proportionality into an equation? Can you tell me?
They're just pretty much equal to, right?
You
Q.
write equal to, and then you have to write something else. You cannot just say equal to. What else you have to do?
After I do Q equal? Or is
You
it
have to use a constant called K.
yeah, K
Now you write down K.
times,
Grams divided by delta T.
and that's the equation I
Now,
will use.
hold on. That's the equation, but this K is, all these Ks are very important. They have their own specific name and they have own symbol. So do you remember the name and the symbol for this K?
For K,
It has to do with heat, so it has to be called heat.
what? I think I know, but I don't want to be wrong.
And this is water. Water is specific. Water is homogeneous. So we call it a specific thing. Whereas a thermometer is not a specific thing because it is not homogeneous. So we call this specific heat. Specific. Oops, I'm sorry. Specific heat capacity, the ability to hold on to heat. That's what we are talking about. Capacity. Or you just call it specific heat capacity. That's the special name for this K, and it has a symbol small c. Small c equals specific heat capacity or specific heat. This is the equation that you are using to calculate Q. So you know grams, right?
Yes, it was 3.9983.
What is the gram for the first reaction?
It was 3.9983 grams.
Yeah, but we had 200 milliliter water.
200 milliliter water, yeah.
So we added that up.
And you had 200.3999.
Good, write it down, 200.3. So 200.3998 grams.
Wouldn't it be 203.9983?
Yes, yes.
Oh yeah, 203, sorry. Because of the dot, huh? It'll be 200.0. So yeah, sorry.
Okay.
So 203.
Okay, this is Q equals.
Q equals, yeah.
Q equals. Multiply that with delta T. What is delta T for this reaction?
I got 35.38.
That was the final temperature.
Oh,
Delta T is final
31.
minus initial.
So it'll be, oh, I wrote it wrong. So that'll be 35.38 minus 25. Hold on. 35.38 minus 25. 10.38.
It was 30.19 degrees.
Oh, I got 31.19 written down. I got to flip it. I wrote it wrong. Sorry. 30.9.
And it was 25 initial. So we subtract that, 5.19 degree is the delta T. 19K. And I told you K and degree Celsius is the same here. Otherwise you have to add 273 to K. But delta T, K is the same as degree Celsius. And specific heat capacity, that C is given to you, is at 4.18. 18 joules per gram degree Celsius. Gram K, it'll be easy to write there. Easy to write that. Now, calculate your Q and tell me what it is.
Okay, for Q, I'm gonna have to use my phone because I misplaced my calculator.
Okay.
8 times 5.19 times 4.18. I got 5016.25.
Nope.
No.
We're talking about question 2 where we're trying to find joules, right?
No, we're just talking about number one.
So I'll do, calculate.
So for number 1, you're just talking about adding the mass to the milliliters, right? Sorry.
Mass to the mass. So we don't want to add mass to the milliliter.
Yeah, so you convert the milliliters given to mass, and
right here. You see it?
Mm-hmm.
So it should just be the 200, and then it's a 1-to-1. So 200 milliliters pure H2O goes to 200.
Plus 3.998 grams.
Here it is.
So we talked about that and we have that. Good. Now, what is the delta T?
5.19.
Okay, and what is the specific heat capacity?
4.18
And what are the units?
is joules over grams times K.
Okay, now multiply all those and get rid of the units that you don't want.
So I'm gonna get rid of, what is it, G and K, right? And I'll be left with J.
That's right, joules. That's what we want. Is that correct?
Yeah, but when I multiplied, well, I did it on my phone. I did 203.998 times 5.19 times 4.18, and I got a big number. But you said no.
4.43 kilojoules.
I didn't get that.
That's what I get.
Yeah, but so he's doing kilojoules, and you're getting joules here. So you just gotta.
Oh, just convert. So I was right, but I just gotta convert.
Yeah.
Oh, okay. You see, Professor, you could have told me that.
So, Professor, when we're calculating the number of moles,
yes.
What is? I'm looking through chapter. That should be chapter 22, right? Energy and work. Or is that?
Why do you need to do that? You know how to convert grams to moles.
Yeah. Okay, you're right. I do know how to do that. Fair enough.
Okay. So who is going to convert grams to mole now? It's going to be Amina or Tram, or who is going to do it?
3.9983 grams NaO first reaction times 1 mole per 40 grams NaOH.
Yep, that's right.
And that will equal 0.1 moles NaOH.
I want 3 sig fig at least, if not
Okay.
4.
And so we're not doing the total grams of the mixture. We're just doing the NaOH, right?
That's right, because NaOH is the one that water did not react.
Makes sense.
Water did not do anything. NaOH is the one that created heat.
Yeah, that makes sense. Thank you.
And then the moles for each reaction is 0.100.
Okay, good.
Anyone else get that?
I'm doing that right now. I'll tell you in 1 second. What was the molar mass of NaOH, real quick?
40 grams per mole.
Perfect.
I want 4 sig fig. Who is ready for the last step of finding delta H?
I can do that too.
All right,
1 mole NaOH, and then it's negative 4.44 kilojoules over 0.100 mole,
excellent.
and then that equals negative 44.4 kilojoules per mole.
Got it.
So in reaction 3, because we're given aqueous NaOH.
Uh-huh.
Or,
Okay.
Can you repeat number 4?
1 mole NaOH times negative 4.4 kilojoules over 0.100 mole.
That's your simple dimensional analysis.
Yes. Okay.
So as we talked about in the class, this is a little hard to do because you have to understand that 1 mole is the starting quantity, and you found the dimensional analysis conversion factor by doing the experiment. That is 4.43 kilojoules equal 0.1 mole. That was found by experimentation. A short way of doing it is that you take 4.43 kilograms and divide it by the moles, 0.1 mole. And then that's a short way of doing it. Because delta H is kilojoules per mole, you take the kilojoules and divide it with the moles, and you have it.
Okay.
So now you do the two other ones. And when you're done, you let me know. It shouldn't take much time at all. But if you have any questions, don't sit
Okay.
there
Yeah, that'd be great.
being
My
confused.
email is
You're gonna send me by email? No, you're gonna send me by Canvas. And if that takes time, you can do it later. That's okay with me.
So in question 3, for reaction 3, because do you just convert the milliliters NaOH to grams just with the molar mass, the same strategy, and then you just solve from that?
Not molar
No,
mass.
you use the molarity.
Oh, molarity, my bad.
1 gram equals 1
1 liter.
milliliter. That's very simple, right?
Mm-hmm.
Yeah.
Professor,
Yes.
can you show how to do number 6?
Show that the equations for reaction 1 and 3, which are given in the background section, add up to the equal to the equation for reaction 2. So let's do that part first. Write down the equation for 1 and 3. I'm gonna give you the computer. I'm gonna get out of sharing and you're gonna share. Okay? And then I can comment as you do that.
There way. I
So
don't
you're
have it on the
checking out.
computer.
Can you do that?
I cannot.
You cannot? Okay. Then you tell me
Working on
what
the
to do and I
computer.
will write it down for you.
All right. It should be equations.
Okay, tell me
At the
what to
start.
write.
NaOH solid plus H2O liquid reacts and form NaOH aqueous. Oh, you want ions?
Either way is okay. You can write NaOH aqueous, that's fine too. Okay, second equation.
HCl aqueous plus NaOH solid reacts and forms NaCl aqueous plus H2O liquid.
Yeah. Okay, now add the two.
And then
Go ahead, add the two.
that's the, so add the products together and
And
then
the reactants together, right? Just like
Correct.
a algebraic equation, you would add it.
NaOH solid
Yeah.
plus H2O liquid plus HCl aqueous plus NaOH solid.
They do go a little bit slowly. I can't.
That's HCl aqueous.
Plus. Okay, what are the other product? HCl aqueous, thank you. Plus,
NaOH solid.
don't. Whew. Okay, good. Now products.
NaOH aqueous or your ions,
Yeah, okay, NaOH aqueous.
and then NaCl aqueous and H2O liquid.
This is, there we go. Now, is there anything on both sides of the equation? Add them up, all everything now.
We canceled the H2O.
Cancel the H2O, good. And we're gonna have NaOH, 2 NaOH solid, right? Right?
Yes.
So we're gonna say 2 NaOH solid. It seems strange because you have not thought about chemical equation as you can add them. That's why it seems strange. Otherwise, once you realize that you can add just like any other equation, it's not much to it, just adding. Plus H2O plus HCl. Oh, H2O is gone. We don't need to write H2O.
That's what I thought too. Okay.
Number 6 also says include energy release per mole of NaOH in each equation.
So we just write down the delta H here. Right, you're right. We need to do that. Delta H reaction equals delta H superscript 0 equals, what did you find? We found 4.43
That's the total, right?
kilojoules, right? Negative
Negative 4.4 kilojoules.
4.43 kilojoules. You want only 2 sig fig? Okay, delta H1, this is delta H2 now. Did anybody calculate that?
Negative 9.80 kilojoules.
That's what I got too. I got negative 9.8. Yeah, 0 kilojoules.
Now, let's look at the third equation. What is the third equation?
I'm not sure.
Well, what is the third equation? We go back over here. The third equation, equation 3, HCl plus NaO, aqueous plus NaOH aqueous. Oh, we are supposed to add first and the third, not first and the second.
Oh, that makes sense.
We are supposed to add first and the third, not first and the second. Okay. So we take this. It would be easier for me to write it down like here, right here. And then copy it over there. The first equation, NaOH, solid.
Should we FOIL it out as ions like they do?
Either way is okay.
Okay.
H2O liquid. H2O. NaOH aqueous plus. That's it. The third equation now. Who is going to tell me the third equation?
The third equation should be HCl aqueous plus NaOH aqueous. And that leads to H2O liquid.
Okay.
There you go.
Now we add this two. Not that underline. I'm going to put a sign, plus sign here. We are adding two equations. And that's going to be NaCl solid plus H2O and H2 are going to cancel out. So this is what I'm going to do. Copy. NaCl solid, H2O is going to cancel out. Instead of H2O, I'm going to write down HCl. Adding now. Plus NaOH aqueous. Equals NaOH aqueous plus NaCl. Plus water on both sides, so water is going to cancel out. No. Yeah.
Yeah,
Water
what?
on both sides, the water is going to cancel out.
Yeah, it should be.
So now NaOH aqueous cancel out, right?
Yeah, perfect. Do you mind if we don't write the cancel out and we just write the completed?
Yeah, that's okay.
Perfect.
So now you are going to write down the heat of reaction over here. Delta H. And you're going to add the two delta H's to find the delta H for this equation.
Makes sense. That's cool.
Okay. Keep on going.
Shouldn't the doesn't the NaOH aqueous cancel out?
Yeah,
Oh, you just wrote it out. Okay, never mind. Makes sense.
good. Yes.
Just curious, the total heat release for reaction 3, what did you guys get?
Negative 5.07 kilojoules.
Perfect. Okay, me too. And so you just add the two total heat losses, right? Releases.
If you added the equation, you are going to add the delta H.
So then we'll be left with, what is it, negative 12.63? Because that first one was negative 4.43 kJ, right?
Yeah.
And then the second one was negative 9.80 kJ. So if you,
It's the third one though. It's the first and the third is what we're mixing.
oh, okay. Oh, I see. I see. I did the first and second.
And so I got a total of, would it just be negative 9.50 kilojoules? Or
For the addition,
yeah,
first is negative 4.43 kilojoules. The third equation, this is the third equation,
mm-hmm.
negative what, 5.07
kilojoules.
kilojoules. Then adding the two up is going to be 9.5 kilojoules. 9.50 kilojoules.
Okay.
Now, what did you get for reaction number 2?
I got negative 9.80, so pretty close.
What do you think?
Yeah, pretty close.
Pretty close. What does that prove? Now the last part, what does that prove?
Hess's law?
Yes, it proves Hess's law. That's what it does. That you can add equations and you can add hits. Yes.
Not too shabby.
Now, it's not exact because this heat of reactions are not very easy to measure. When you measure heat of reactions, there is a certain inaccuracies that has to go, it always goes in it. That's why it's not going to be exact. Okay, calculate the percent difference. You can do that. No big deal. State your own words what it means to mean by additive nature of heat of reaction. You can do that. Post lab, there is one post lab that you have to do. That's all there is to it. Okay, you do that and you give it to me later. Now we're gonna go talk a little bit about something else. 3:52, take a 8-minute break, and at 4 o'clock we'll talk about something.
Hey, Professor.
Yeah.
To find heat release per mole, are we still going to be are we just going to change around the equation for Q? Or is there just like a simple one-to-one equation we can do?
Q is for grams and delta H is for moles.
Mhm.
Does that help you understand that?
Yeah, I'm trying to.
If it is NaOH, then you are going to take 40 grams per mole. And if you do use 3 grams of NaOH, you are going to do the proportion. Both of them are heat, so both of them are kilojoules.
Okay.
It's just one is for grams and one is for moles.
So to set up for calculating that delta H, it's 1 mole NaOH times, let's just say for reaction 1, then our kilojoules we calculated over the moles we calculated.
Right. Or if you want to do it more simply, this makes more sense to me because I can see the I can see the dimensional analysis. Or you can just take the kilojoules and divide it by the moles because those are the units.
That makes sense.
Okay, it's 4 o'clock. We need to change things. Enough. We had enough discussion about this. We pretty much did it together. The whole thing is pretty much done, except for the last part. All right. Going to get out of here. And get out of here. And okay. What's happening next week? 329 is when we are going to use our guidebook 3. So we'll get it together either on Monday or on Wednesday. We'll have it, but it's going to be in the Canvas already, so that's not a problem. But the one that we are talking about is the paper copy that you can pick it up from my house next week sometime, or it will be available for those guys, 7 or 8 people who are going to go to the campus. You can pick it up while you pick up your drawing board and the molecular model kit. So unit 25, that's atoms chapter 7. Atomic chemical spectra, BL, unit 26, that's what's happening there. Quiz 6, unit 20 to 22 is going to be on, I will open it up on Sunday or something like that. No, actually, I'm gonna give it to you next week, not this week. Quiz 6, unit 20 to 22, I'm gonna give you next week. I saw that you needed a lot of help with this this lab. To me, it tells me that you are not ready.
I
for the
agree.
quiz.
I don't feel ready for it.
So I was thinking about giving it to you on Sunday, but I'm gonna give it to you next week.
I really wouldn't mind if we could just, I know it's a fast-paced class, but if we could just maybe take a little extra time and just do some practice problems on these like last couple units.
Well, that's what we were doing right now.
I know, and it's helping. It definitely is helping, but if we could just go over some more examples, I think that would help solidify it for me. We don't have to do that right now. I'm just saying in the future, just before like the next exam or something like that, just to make sure we get it.
No, I'm gonna tell you when we're gonna do it. That's what I'm saying.
Okay.
So on Thursday, we are going to do the lab and we are also going to do that. And right now we are going to do a little bit of entropy business.
Professor? Professor, can you hear me?
Can't hear you.
Okay. Can you hear me now?
Yeah.
Okay. So I know you sent out an email yesterday. I'm pretty sure it was for everybody. You talk about the grade where if it's you get the 42 or lower, you drop, like considering dropping the class. And I was just wondering, is there any way that maybe consider curving the grade for a lot of us? Because I do see the
I understand
high
what you are
amount for
saying.
us,
What we
for
can
those of us
do,
who get Cs.
those
And
people
then-
who are getting 60% or less, in my experience as a teacher, these people don't survive this class. Now, I'm not a god and I cannot tell you what's going to happen in the future, but this is what my experience as a teacher said, that means you do not understand enough chemistry to pass this course. Now, I can be wrong. I'll be happy if you can prove me wrong, but that's what I would say right now.
Yeah, no, that's understandable. But what I'm saying
Yeah,
is people.
That's what I would say right now.
Yeah, but I'm saying like, I'm just making a suggestion for those people who actually trying in a class or turning in work and considering coming to your office hour and stuff like that. Have you considered curving the grade? Like
The grade is
for example, if
what we
us like
decided,
having
what I told you at the beginning on the syllabus. That's how the grade is going to be. That I am not going to change.
So you wouldn't consider curving the grade for us, any of us? I
I don't understand what you are asking for.
So curving it, so in like rounding it up to, so let's say if we have like for example, if someone have like a 78% or 79 point something percent, would you curve that up to a 80% so we receive a B instead of a C?
80% is a B, and 90% is a A, and 70% is a C. Now, at the very last moment, I may change that, but it depends upon other factors that I don't want to talk about right now. And right now, I will not commit to that.
Okay, but
But I would change it, anything like
in
that.
mind?
So so to make it clear, you said if you have like a 60 or below overall in the class, then you should consider dropping. But if you have
You
like,
should highly consider dropping, because in my opinion, people with that kind of grade do not understand enough chemistry to pass this course at the very end.
yeah, I'm just trying to like clear it up. But you said if you have like 60% right now in the class, then you should consider drop it. But if you have above 70, you're still okay, right?
It should work. That's what I would say. Though, if you are between 70 and 80, you do need to put in more energy, and you need to come at the class at 12 o'clock in the afternoon, and also, take advantage of office hours and also the STEM hours, because you can make it, but there are some misconceptions that are making it difficult for you. And if those misconceptions are not cleared up quickly enough, then they're going to cost you more. For example, I give you a misconception. I was talking with some students, and one misconception is understanding what is an ion. And therefore, at least 4 or 5 students are not writing the charge on the ion because they don't understand what an ion is. And that's a very fundamental thing about chemistry. You must understand what a molecule, what an atom, what an ion is, and how they are different from each other. And if that is your case, then I need to sit with, or somebody need to sit together with you right now, today, tomorrow, day after tomorrow. Is getting late already, and get that together. So that's an example of a fundamental misunderstanding. And if you don't take care of it, it costs you a whole lot. So make a plan if you have fundamental misconception. And I say that if you are in the 70 to 80 grade, you have fundamental misconception there, but that can be remedied. If you are 60 to 70, maybe not, I'm not sure of it. If your grade is below 60%, very unlikely that it can be done at this point in time. But as I said, I'm not God, and I cannot tell you what the future is going to be. One thing that I don't like at Strabao College is that they don't have A minus, B minus, B plus, anything like that. I really like that. A minus, B plus, that makes more sense. Most colleges do that. But we don't have it at Strabao College, and that makes life harder for me.
Yeah,
Because-
so that's what I was saying. That, like if we get like let's say we get like a 79.13% or something like that, that would
It's a headache for me. I really have to think. I agonize over it. Let me tell you. If that
Okay,
happens,
can you think
I will
Right.
agonize over it, and I'll have to decide then. And then at that time, I will think about it and see what I can do about it. But
Okay,
right now,
sounds good.
I will not tell you.
I can take
But
that for an answer.
It's a hard decision. It takes me a day or two to think through it. And I don't like that, but yeah, I would be much easier for me to, and also fair to the students to this, 78% is a minus, a B minus. Now that makes sense to me. But to say 78% is a C, it doesn't make sense to me. But my hands are tied. I cannot do anything about it. What I could do, I did when I had a chance. At Strabao College many years ago, they asked the teachers, what should you do? Should you give A minus, B plus? And I said, oh yes, that's what we should do. More teachers said no, and therefore now we are still stuck with this arcane system that I don't like, but I am stuck with it, and you are stuck with it. One thing I would suggest you do, it may not help you, but might help somebody, is to, write to the dean and complain about this. And if you want my voice in there, I will put my voice in there too. I would say it's not fair.
But isn't it kind of up to you to round up the grade?
I wouldn't call it rounding of the grade. I mean, I can, but this is what I decided that this is what needs to happen in order for somebody to show me that they know this much chemistry so that they can have a B. And there is, you're right, I have to make that line somewhere. You're right about that. And I have decided to make that line at 80. Now it will never go 81 or 82% like it happens in UC Berkeley or somewhere else, some other universities, where 92% can be a C. That will not happen with me. If you have 80%, you got a B, no question about that. It doesn't matter how many people got A's, how many people got B, it doesn't matter to me. But, 79.5%, I can see that, that's rounding off. Okay, you're talking about rounding off. I can round it off 79.5 to 80. That I can do without any problem. But
Professor,
after that, I have to think about it.
Professor,
Uh-huh.
sorry, what page is this?
What-
That you're doing?
We are not on any page right now. We're just talking
oh, you're
about this
showing
other
right
thing.
Yeah, I was just trying to get there so that when you do go back to that
Okay,
page.
we are on page, okay, 18. Unit 21 calorimetry. Unit 22, we are on unit 23. The page business is 46. No, after that, there we go. 40, 48, 49, that's what we are talking about.
Okay, thank you.
Now, what I want to do right now is that I want you to understand the basics of this entropy business. For half an hour we have, I just want to go into that so that you understand the basic idea of entropy. That's what is said. Once again, if you understand the basic, your life is easier. So that's what we are doing now. Okay. We talked about what is common between these processes. Entropy, increasing disorder is common. When disorder increases, a reaction becomes spontaneous. That's what we are saying. And therefore, if we want to talk about when a reaction becomes spontaneous, we need to learn about disorder. And if you want to learn about disorder, we need to have a better name for it. And a scientific name that goes with measuring the amount of disorder is called entropy. Enthalpy and entropy. Now we have entropy, and entropy is another parameter of a system, another characteristic of a system. Like we have temperature, we have pressure, we have volume, we have those parameters of the system, and we also call them properties. Like this, unit 20s, properties of systems, temperature, volume, pressure. System also have delta H as the property, enthalpy. And systems also have entropy as the property. And so this entropy is going to have a symbol. And it's going to have a symbol that is called S. So big S is called entropy. Big S. That's the symbol for entropy. And entropy is a state function. What does that mean? That means you can say final entropy minus initial entropy equal change in entropy. So delta S equals S final minus S initial. Very easy to find the entropy of a system because of that, because change in entropy is what we are interested in. Now, Change in enthalpy is also what we are interested in. The difference between entropy and enthalpy has to do with joules, of course. Entropy does not have to do with joules. It has its own units, which are, we'll talk about. There is more, so we'll talk about that. But right now, we're not going to talk about that. So entropy is measured in joules. Enthalpy is not measured just in joules. Entropy is a measure of the disorder. Enthalpy is about heat of the reaction. So that's the difference. Entropy can also have, entropy can be measured easily. Enthalpy or internal energy of the system cannot be measured easily. Delta H can be measured, but H cannot be measured. But delta S and S both can be measured. That is the difference between entropy and enthalpy. So you can measure S and you can measure delta H, delta S. And how is that? That's because when is there no disorder? If we are talking about a system, when would there be not any disorder in the system? For example, we take 1 mole of hydrogen gas, 1 mole. When do you think this system will have no disorder in it? What does that mean? Not having any disorder. What makes things disorderly? Talking about chemical reaction, talking about chemicals, what makes them disorderly?
When they change form.
Yes. So changing form could make it disorderly. For example, you have a piece of paper and you are writing on it and it's a clear piece of paper and it's just do fine. And then you crumple it. So changing form, very good. What else? Now, disorder has to do with movement. If there is more movement, there is higher disorder. So movement has to do with what? Movement of particles, movement of ions, movement of atoms, movement of molecules. When do they move fast and when do they move slow?
Slower at lower temperatures.
Yes. So entropy has to do with temperature. Now, we know that at 0 Kelvin, there is no movement. What does that mean? Is there any entropy at 0 Kelvin?
There's no disorder.
No entropy at 0 Kelvin if the system is organized in the proper way, and if the system is pure system, then there is no entropy at 0 Kelvin. Therefore, entropy can be measured. And entropy is directly inversely proportional to temperature. Therefore, entropy is measured in the units of joules divided by Kelvin. So if we are talking about 0 entropy, there are 3 things, there are 3 parameters, there are 3 requirements that we need to fulfill. First of all, it has to be, the system has to be at 0 K. 0 Kelvin. Okay. Okay, at 0 Kelvin. Number 2, the system has to be pure. It should not be messed up like a piece of paper that has been crumpled up. It should be in the proper order. So the order of the system should be fine. And that we call crystalline system. Crystal has order. Crystalline. Crystalline. It has to be crystalline system, meaning it has to have the pure internal order. And the third thing, it has to be.
Sorry to interrupt you, but This has nothing to do with what we're doing right now. It's just I just seen something on Canvas right now. It's for quiz 5, the unit 18 and 19. You said it was due today at 11 a.m.
The quiz was due today, that's right. Okay, so the third thing is pure system. So if you are talking about gold, we are talking about pure gold. We are not talking about 12 karat, 14 karat gold. If we are talking about iron, we are talking about pure iron. We are not talking about steel. That's what it means by pure system. If we are talking about water, we are talking about pure water. So these are the three properties that are important. So if these three properties are there, the system has zero entropy. And therefore entropy can be actually measured. And the measured entropy for all these chemicals is found in a table, and that is available to you all the time. So you know you have the table available for delta HF. Heat of formation. You also have the system available for S. And there is no delta S here. There is just S because entropy can be measured. Now, for the little time that we have, I'm going to open up, and if you have any questions, that's what we're going to do. We're not going to do anything more than that. So that's that. Question time. Or if you want me to go into anything else, this is your time.
Oh, you've heard? Straight foolishness.
And Tram, I have a little harder time listening to you, I guess, because for some reason it's not loud enough.
Do you think that you can extend the quiz that was due this morning till tonight?
Why?
Because a lot of us thought it was due tonight, and you're
Well, this is hard for me to understand. I'm sorry, but it says clearly there that, and I gave you, I thought it would be easier for you guys if I give you till 11 o'clock, and Sunday I gave it to you, and I send out an email saying, this is what the times are. So it is getting a little hard for me to understand what's going on.
Yeah, because sometimes like a lot of time your stuff are due like at the end of the night. So, you know, I just thought that it was due at today at the end of the day. On our paper yesterday, it just showed that due tomorrow. And then now I look at it again and it is.
I send it out an email too saying it is due at 11 o'clock.
Okay, do you take points off for being late?
I will think about it and let you know. Let me think about it in 10-15 minutes before the class is over, okay?
Okay.
Hey, Professor, I actually had a couple questions about the quiz, but if
Yes.
people are still going to do it, should I just hold off for private?
Yeah, just hold up, right.
All right.
The other problem with this is that some people might find it unfair that, you know, they had to do the quiz in record time and then whatever, they had to bust their asses, and now some other people are getting extra time to do the quiz. So this is what some people could feel that way, you know, some other people. So that's the thing I need to consider. And please do pay attention to what I tell you, because I had a hard time with experimental write-up, experimental report, where I clearly told you that I want the report this way, and I gave it to you, and it actually makes it easier for you to do the report. And it takes me 3 hours to put it together. It has to be flawless. You cannot have any mistakes in there. This is part of my problem, that whatever I put it on the computer has to be flawless, and it's not an easy thing to do. As you have seen over and over again, there are little mistakes here and little mistake, this little typo here and little thing over there. And then he would say, oh, this happened and that happened. And then, of course, I look it back into it and I say, okay, this is right. They should get point for it. So I give you the points. I have to do that, of course.
Hi, Professor.
Yes.
The homework, that's 21 and 22 or 20 and 21.
Yeah. What about it? That's due
Um,
Wednesday evening.
oh, okay. I'll work on it then.
I mean, if you guys want to, you can do the homework right now for the next 15 minutes. That's fine with me.
No, it's
ask me
fine. I'll talk to you and
Also, I understand that, everybody is busy and you have other things to do in your life. And then again, if you can be in the office hour, why not be in the office hour? You do your homework and ask me questions. I don't mind at all. And you get your homework done or whatever you get done. That's great.
All right, Professor. It says the Unit 20 and 21 homework's due tomorrow, so you're going to ship that for Wednesday. Just checking.
I wasn't sure about what the day is. It's due on Tuesday because then on Wednesday you can ask me questions about it. That's why it's due on. But
So
if
it
you
is
want
due
to,
on
I can make it
Tuesday.
due at 11 o'clock in the morning on Wednesday. I can do that.
well, no, it's just if I don't have time to ask you questions right now, I'm gonna ask you questions about it. But if it's due on Wednesday, I can come into office hours and ask you in office hours.
No, office hour is on Wednesday evening.
And so it's due Tuesday night though.
All right, I'll make it due Wednesday night. Okay.
Okay. It's just the first couple of questions are kind of confusing and I'd like to try them on my own. But if I
Well-
have you and this is the only time I have, I'm gonna ask you.
Also, it should be easy now that we have done this lab.
Okay,
It should be easier anyway.
okay. Yeah, I just wanted to make sure. I wanted to clarify.
Good,
And
good.
thank
I
you,
like-
Josh. I didn't
I like
realize
that
that.
you want to make sure.
Thank you, Josh. I didn't realize it said the 23rd, not the 24th.
Problem at all. I'm probably going to start working on that right now because I have work tomorrow, unfortunately.
So do what you want to do. If you need to go, you can go. If you want to hang around with me. And I can be here for 20 more minutes instead of 10. I can be here till almost 5 o'clock if you want to. Then I need to go take my greenhouse down. Tomorrow is gonna be windy, and if it is out there, it will be blown over, and all my growing plants will be in trouble.
Professor, I think the SEC law experiment due date, I think you need to update that as well. It's saying June next week on Monday.
Which experiment?
Yes, SEC law experiment.
Yes,
The one
it's
we
the
just-
experiment we just did it today.
Yeah,
And
the one.
we did all the calculations. I don't know. I don't understand what you're talking about. There is only one thing you need to do, right? That
All
one
right,
question.
I'm just saying maybe if you can update that on Canvas.
Update.
Yeah, the due
I-
date, because it's saying it's due next week instead of today.
I update. What does that mean?
To update the due date, like
That's
instead of-
not called update. Update means to improve, to change. That's what update means.
okay.
Now, I have not told you about the date, the deadline for that experiment anyway. I just told you you should be able to finish it today because I think it is so simple. But it was not simple for you, so we went over the calculation and it's pretty much done except for one problem that you are supposed to do for the post lab problem. So you got 9 points done. That's how I see it. And 1 point needs to happen. And how much time would it take to do that 1 point? 15 minutes, half an hour, something like that. But I have not given you deadline even. I said, get it done and quickly. That's what I said. I haven't given you deadline. So nothing to change the deadline if I did not give it to you.
I thought like on Canvas there is a date, so I just wanted
I
to
thought
make
you
sure.
could get it done today in the class. That's what I thought. Really, I did. Because there was nothing. I mean, there is equation, Q equals this, delta T and C and multiplied by mass. And then you have to do those 3 calculations. And then you have to change it into delta H, which is just divided by moles. So I thought it was very simple, but it took a long time for you guys to do it. Okay, fine. And I helped you out because I understand, that's what you need to do. That's what we need to do. So that's what we did. Now, you understand that most of the experiment is already done?
Yes.
Yeah. You don't have to do anything you don't have to go into the virtual lab. There is nothing that you need to do there. We did the whole day experiment and we did the calculation except for one little part. So,
Okay, thank you.
so that should not take much time at all. That's what I would say. And then I did not even say, get it done this time, but I said, get it done quickly. And you should be able to do that. That's what I think. Okay.
All right, thank you.
Yeah.
Yeah, but some of us are not as fast as you are, Professor, and you should be glad we're asking questions and asking for help instead of staying quiet and not getting it.
Instead of saying what?
Instead of us staying quiet and not getting it, you should be glad we're asking. You're reaching out for help, so you shouldn't be mad.
What did I say like that? Did I say what?
You sound mad.
Huh?
You sound mad.
I sound mad.
Yes.
I sound impatient. I don't sound mad. I'm a little impatient. That is true. Because when somebody says deadline, extend the deadline, and I understand, English is my second language too, so I understand that. But when thing like that happens, at times I get impatient. And also I felt this experiment was so easy to do. There is little calculation, not much. And it took us a long time, but I went through that. And while going through that, I became a little impatient. You're right about that. Yes.
And I understand you too, but then like sometimes hearing you like that, maybe next time they're gonna be afraid to ask you or even tell you what's going on. I understand you too. Trust me, I have kids and I get impatient all the time. And sometimes I'm like, maybe I shouldn't have, yelled at them, or maybe I shouldn't have spanked them or something. I understand you. I'm just saying you sound a little bit mad. Can you smile?
Okay.
What made you laugh? Better than a smile. It's just, like me, I'm like, I'll be afraid to ask you again, if like, say I fell behind on something and I my day was so crazy that I forgot to email you, then if I want to catch up on it, I'll like try to email him like, no, he's going to get mad. I'll just forget it, There's always two sides to everything, You're the teacher and you have tons of students, and I'm sure you hear all these excuses. But sometimes people really need that extension. Can you smile again?
Yes, I know that too. I need to remember these things. Yes.
No, I understand. I mean, sometimes I'm wrong. Most of the time, I don't understand this, and I'll Google it and I'll try to figure it out. But I still ask, even if it's if I hear nobody asking, I'll ask you. And if you get mad, it's okay. I'll smile while you're mad or impatient. There you go.
I am not getting.
Well, impatient. I'm correcting to your words. Impatient.
I get impatient when I don't hear anybody saying anything. When I say your name or somebody else's name and they don't say anything, that doesn't feel good to me. And if I want to
see now that
you, then what I hear you saying is that I need to give you a little leeway.
See,
I,
now that you vented and let us know how you feel, I think we should step it up and like, even if we don't know the answer, we should say something, right? That's what
yeah,
you're,
or, you know, or say, right, thank you.
or
thank
say,
you.
I don't know. So then
Yeah,
that you
yeah,
know that.
that- yes, yes, yeah.
Okay, so you're gonna hear more of my voice then. Telling you at least I don't
I
know.
need to have more of a smile on my face. I understand you very well. Yes.
And I'll be here to help you through that. I'll just be like, teacher, breathe and smile, and then you'll know it's me.
Yes, yes. Breathe and smile. True.
But don't get impatient. It is not good for your health. Trust me. You see, I got people to speak now. Can I get extra credit for that? I'm just kidding.
No, you can also say, I made the teacher laugh instead of growl. Can I get extra credit for that?
Well, that's double. I like you. I'm gonna speak more even when I'm super wrong.
I like you too. I appreciate you telling me these things.
No, I just felt like like us as students, we should understand how you feel, and you as a teacher should understand that. And I think that will bring the best, you'll have the best output that way. Because then you see where we're wrong, and then we see what we need to do to make you want to help us more and not just get impatient.
Yes. Oh, yes.
All right. All right. So can you smile? You're like, no, not no more.
Not smiling anymore.
You're like,
it's almost 5 o'clock. I need to go.
Okay. No, I just wanted to let you know. Sorry.
No, just one. That's we are appreciating each other. So that's good.
Yeah. Okay, back to the lecture, I guess.
Okay, let's fly a kite. That might help us. I used to fly lots of kites when I was young. No, I don't have one, and I have not invested into that and investigated into that. I did look into that, but I have not done that. It would be definitely easier if I can write with a pen. And I got a contraption like that, but I did not learn how to use it. And I have not done that yet. And it's partly because I am not, I should do that, but it's partly because often I'm very busy with the class. This is like teaching for the first time because I have to do all this extra stuff because we have to work on the computer. There's a lot of extra stuff that I need to do. And that takes a lot of amount of time. And I'm glad I'm teaching only one class. If I would be teaching two classes, I don't know what I would be doing. So that's why that's good that I'm teaching only one class. And it's like I'm ahead of the class by 2 days or something like that. And I realize that is also similar for you. I mean, it's not easy, as we talked about Zoom fatigue, And so I have starting to put that into my equation also. Okay, let's ask everybody, anything we can do now for 10 more minutes or 15 more minutes? Diago, you have anything? Specific? Okay. Joshua, you have anything specific?
All good.
Cindy, what about you?
No, just need you to smile.
You'll make me smile yet, Cindy. Or laugh even.
I know, I like that.
Thank you.
I like that.
No, I have been changing myself recently. I decided, why should I not be smiling most of the time in my life?
Yes, no, you know,
Especially considering what's going on in the world, and I don't have COVID, so why shouldn't I be smiling?
yes, you smile. And then when you're impatient, it's not good for your health. I learned that.
That is correct.
Yeah,
And early in the morning, I get up and I remind myself and I smile. And when I do my yoga, I make sure that I smile.
Yes.
And that's last month, I have been changing myself. So I take your advice.
Yes.
Professor, are you happy?
It's a nice advice, good advice, yes.
Yes, I'm telling you, because I'm telling you, I get impatient with my kids and I'm like, oh, you know, but then when I calm down, I'm like, dang, I could have done that differently, you know. I wouldn't have gotten mad. They wouldn't, you know, they wouldn't have to see their mom mad like that.
Right, yes.
Then next time something happens, I'm like, all right, woosah, smile, and go talk to your kids now, you know, gotta stop myself.
Yes, oh yes.
Professor,
Lisa, anything specific?
Professor, can you hear me?
Yes.
Oh, are you happy now?
I forget sometimes that you guys can see me.
So if you're happy, can you give us an answer if you're gonna extend the quiz that was due this morning till tonight?
You are very diplomatic, aren't you?
You're right. I need to get my grades, and you know I'm on it, on top of it. I'm actually on it a lot of time. I just don't know why what happened. I just assumed that it was due tonight. That's why I was gonna do it after class, but I didn't realize that it was
I
due
need
this
to
morning.
ask the other people who did the quiz, would they mind too much if I extend the grade? And I am putting you guys on the spot. You don't have to say anything or whatever, but if somebody has to say something, this is your time.
Professor, there's literally 7 people in here, and these people should deserve the extensions. Majority of us are here.
Yeah. I don't care either. I took it also. You can extend
All
it.
right, I'll extend it till tonight, 11:59.
Thank you.
I will hope to extend it. I don't know. I'll have to look into that and see that. And then somehow do it, send you an email if I need to do that, okay? That's what I'll try.
Thank you, Professor. See you Wednesday.
All right,
Bye.
now smile.
I'm always smiling. I'm always smiling. Life is too beautiful not to smile. Regardless of what we go through, we got to smile.
Yes, that helps. That helps.
I learned that. I had got sick a couple years ago, and it was really, really bad. Doctors weren't sure if I was going to live or not. So,
oh, wow.
I felt in this like dark place where I didn't want to leave my room. I wasn't eating. I lost like 60 pounds in 1 week. It was really bad to where like I didn't want to live no more, you know. But then I like started like just bringing myself out of there because I have my kids, and I'm like, what am I doing? You know?
Yes.
And then like I didn't have like the support that I needed at the time. So then I started searching like myself, like how to make myself, you know, be better than what I was doing, how to accept what was going on and how to live, you know.
Yes.
But I started talking to counselors, I started talking to people, and I accepted that I'm sick and I'm going to be sick probably the rest of my life. But I'm just like, you know, I just got to try to make every day the best out of it, you know? So for a distraction, I came back to school, and it helps because then, you know, I meet people and we talk, and it's just cool. And yeah, and I'm here and I smile every day. If you look at me, you won't never know exactly what's wrong with me unless I sit here and I show you and I tell you. But yeah.
Everybody, this is very important to hear.
Yeah, I'm like, I'm sorry, I told you guys my business, but yeah, I suffer from an immune disease, and it's a mixture of a whole bunch of stuff where the tissue in my body is at war with itself. So I do have pieces of tissue come out of my body sometimes. They can't control it. They give me medicine to try to help control, but it doesn't really work.
Uh-huh.
And then I suffer from rheumatoid arthritis. Then I have Raynaud's, and I have like my white cells tend to drop a lot. Sometimes my blood platelets, so I get bruises all over my body, my nose bleeds. Like I spit up blood when I brush my teeth, as I have a bloody mouth. It's just different things. But
Mm.
I'm smiling and laughing. So yeah, don't ever get, what did you say? That one was not mad,
Yeah. And
impatient.
then I, as a teacher, try to remind myself that I don't know anything about your rest of your life. I mean, all of my students, I don't know anything about the rest of your life. What kind of trials and tribulations and challenges you have, I don't know that. So I try to, as much as possible,
Yeah,
remember.
and I mean, I'm like, that's why I'm one of the ones that usually ask for extensions, but that's because like when it's cold outside, I have Raynaud's, so I lose circulation in my hands, and it's hard for me to like write. So sometimes I will have my daughter like write for me, or sometimes we're in class taking notes and she's out of her class early, so I'm like, hey, come help me, and she writes notes for me because I can't. I lose feeling in my hands, and it's impossible for me to even pick up the pencil. So that I'm one of the ones that, like, sometimes once in a while I'll ask for an extension here and there. So sorry for that, but yeah.
Sorry for that. This is important for us to know these things. No, not to be sorry. And don't be sorry about it. I mean, I can tell you about my life too, and that's I
Yeah.
have an autistic son, my only son. He
Uh-huh.
doesn't live with us. He's 24, and often he refuses to take shower. And I won't even tell him to take shower because that doesn't work. Then he would feel rebellious, right?
Yeah, because when you tell them to do something, it's like they don't want to be told; they just want to do it. And when you tell them,
Yeah,
they're like,
yeah. So I say, I keep a smile on my face when I'm with him, even when he hasn't taken shower for many days.
oh my
That's
goodness.
how it is. And I don't tell him to go take a shower. That doesn't work.
Yeah.
Anyway, we, all of us are
Yeah.
here in this world because we have something in our life that we need to learn, and we need to face the challenges in order to learn that. That
Yeah,
is true for all of us.
I've learned
Some
that.
have more and some have less. And
Yeah.
sometimes you have more and sometimes you have less. Yes.
I used to ask, why me? Why is all this happening to me? Like, what have I done?
Uh-huh,
And I realized that I can't, that's a question that's just going to stress me out because I'm never going to have that answer. So
Yeah.
I just accepted that whatever comes across the way is it's just preparing me for the worst. I'm just getting prepared to like learn how to take things and be good with it. And then
Yes.
when the worst
Yes.
comes, I'm calm and I can accept certain
Yeah.
things. I've learned that. But yeah, thanks for hearing me out, I guess. I made you smile. I told you a little bit about my life.
Yes.
And
Take a deep breath and keep on going.
yes, and smile regardless
Yeah.
what smile, because that's healthy. So hopefully the 7 people that are here start speaking up even though they don't know the answers. Okay, you guys, I'm gonna take a picture of who's here and then I'm gonna call on you. No, I'm just kidding.
I try to speak up. Yeah.
I know he did talk. I heard new voices today, including mine. Well, I don't always. I talk, but not that much.
I try to talk every day.
Oh, you always talk, Josh. We know that. Yeah, I know. I'll try to talk more. It's just like sometimes I'm afraid to be wrong and like get put on the spot because you be doing that, and I don't like that. So then I just wait till somebody asks the question or try to figure it out. But yeah. But thanks, Professor. See you Wednesday.
Oh, you are welcome. And okay.
All right. Bye.
Okay. Bye.
Have a good one, guys. See you Wednesday.
Bye.
Bye, everyone. Have a good day.
So long.
And Professor, you're still doing your after hours on Wednesday, right?
Yes. 5:45.
5:45. And then the homework for 20.